you've done lots of math before, but just in case you need to review, I do have those towards the end of this video. So let's do 10. It says a 100 square mile area of national forest is how many acres? So I know area, if you remember it from math, area is this side times this side, so it's 100 square miles, which they've already given me the area. So I'm going to write miles mi squared, okay? Is how many acres and how many hectares. Oops, I didn't put the cutout of the conversions up here. But if you look at the conversions at the very top of your review sheet, there is where's my equality? Yeah, the very first one that says 1 mile square is equal to, I should write it down, 640 acres, right? Lucky for us, it's already in area on one side and the other. So in this case, I'm just going to quickly use this equality really quickly. If 100 miles square, basically, I have to figure out how many acres that is when I know that 1 mile square is equal to 640 acres. Okay, and I'm just going to put AC, even though that's not really correct. My miles squared cancel out, so I end up with, and this you can quickly multiply right in the top of your head, right? 640 plus these extra, and tack on these extra zeros. So 64,000 acres. I'm going to write AC. That's for the first part. But how many hectares is that? Well, at the very bottom, there's an equality that says 1 acre equals 0.405 hectares. And I've run out of room, but you guys know that it's there. All right, so that's it. It's just that equality. I'm just going to multiply by that equality. I'll put parentheses in this one to stop making it so messy. My acres needs to go on the bottom in order to cancel it out. 1 acre is 0.405 hectares. And when you write out that answer, it's going to be in hectares because my acres canceled out. And I won't do the math here because I don't have room, and you guys have the answer to that. A city that uses 12 billion BTUs of energy each month is using how many kilowatt hours of energy? So 12, you can write out all the zeros, but that's too much for me. So I'm going to write it in quasi-scientific notation. I say quasi because I'm just going to write 12 times 10 to the 9th to be really quick. Real fancy scientific notation would always say 1.2, times 10 to the 10th instead of this. But this is my shortcut for today. BTUs in 1 month. Okay? I'm going to write that down just so that in case I might need it later. I'm going to write mo. Is using how many kilowatt hours of energy. So I'm going to look at my list of information here. And let's see if I have something that can immediately convert from BTUs to kilowatt hours. My list says 1 kilowatt hour is, oh, look at that. I do have a quick equality. 1 kilowatt hour, it's the third one, is equal to 3.4 times 10 to the 4th BTUs. Oh gosh, I ran out of space again. You make sure you keep track of your units. I'm sort of not able to right here. Okay, so I know 1 kilowatt hour equals that many BTUs. I'm going to put my BTUs number at the bottom of this fraction because I want to make sure that BTUs cancel out. I'm not talking about BTUs. I have to end up with kilowatt hours, right? BTUs. Pretend that that says BTUs beautifully. It's 1 kilowatt hour. And I'll write the whole thing so that you get used to seeing it like that. See, BTUs cancel out, and I end up with a number that's going to be kilowatt hours per month. And since this doesn't ask me to give it per year, I'm going to assume that it still means per month. And the way that I do this, you can do it a couple of different ways. Since I've already got it in scientific notation, This is, what was this? This was a 9. That's a 4. So just so you can follow along really quickly, I'm gonna subtract my powers first, right? When you divide powers, you're just really subtracting them. So at the bottom, I'm gonna have 1. 9 minus 4. I'm gonna have some 10 to the 5. All right. So I'm gonna know that I'm gonna end up with something times 10 to the 5 BTUs. Oh, I'm sorry, kilowatt hours. All right, now let's work with my 12 divided by 3.4. So I can't use a calculator, right? Remember? So I actually have to do the longhand division of 3.4 divided by 12. I could have used this number to be 3, so I know it's going to be not quite 4, and if this would have been 4, it's not quite 3. So something in between 3 and 4. And if you actually do this entire multiplication, or I'm sorry, division, you'd actually, I don't have room here, I'm sorry, it ends up being 3.5. Then all I have to do is put that in front of my times 10 to the 5th per month, and you can keep the per month if you want. All right, next page. 1 barrel of crude oil provides 6 million BTUs of energy. Oh, wow, that already tells me the information. 6 times 10 to the 6. I always like to convert when I'm using really big numbers like this. BTUs, million is times 10 to the 6th, are found in 1 barrel. I'm going to write 1B of crude oil. Ooh, that looks like a 6. I don't want to do that. I'm going to write BA. How many BTUs of energy will 1 liter provide? All right, so I know how many BTUs are in a barrel, a big old barrel, right? Let's see if I can convert directly from barrels to liters. Looking at my list of conversions, it says 1 barrel of oil is 42 gallons. Let's see, but I want liters. Does it give me something directly from barrels to liters? Kilowatt hours, metric ton. No, but it does give me liters to gallons. So in this case, I'm going to have to do a double sort of little conversion, one little step at a time. Oops. And I'm going to start with whatever converts from barrels to something else, right? Because I might as well cancel my barrels first. Let's see what my list says. My list says 1 barrel of oil is 42 gallons. Okay, so 42 gallons. I do it in this way so that my barrels cancel out. All right, so now I know that in 42 grams of oil, I'm sorry, gallons. So let's write gallons. Gallons has this amount of BTUs, but I still want to know how many liters there are. So if I remember correctly, there was a conversion from gallons to liters, right? And that number was, where is it? I lost it already. 0.264 gallons and 1 liter. I'm doing it this way so that my gallons cancel out. And whatever I end up with will be BTUs per liter. Let's see if that's what it is. How many BTUs in 1 liter? Perfect. All right, so I'm going to multiply this out. So I do a tiny little shortcut before I start multiplying big numbers like this because that's crazy. I remember that you can divide 6 into 42 7 times. 6 times 7 is 42, right? So it's going to be 1 times 10 to the 6 BTUs times 0.264 gallons divided by 7. Now I know, hey, wait a minute, this is already in a decimal form. Times 10 to the 6. You can actually write that. 0.264 times 10 to the 6. Or you can write it in a nice normal scientific notation where you would write 2.64. Is it 2.64? Yeah, 2.64. Times 10 to the 5th, or you could just write 264. Oops, that's not right. I don't want that there. 264 times 10 to the, let's see, 1, 2, 3, times 10 to the 3 BTUs. I hope I did that correctly because I did it really, really quickly right now. And then start multiplying that out. Or dividing that out in this case, because it's 264 divided by 7, whatever that is, times 10 to the 3. So then I divide this out. I end up with something like 37.7 approximately times 10 to the 3. But if I want to write this nice and formally, I would write 3.77 times 10 to the 4 BTUs. Oh gosh, this is really slow to write. Don't forget to actually write down the unit. Or you can write the full number, which would be 37,000, approximately 37,700 BTUs in 1 liter. Okay? Hopefully I wasn't too fast there. How many calories of energy will 1 gallon of crude oil provide? Well, I should have reminded you, I should have somehow written that. You're going to have to use the information that you started off with up here, where it said 1 barrel of crude oil provides 6 billion BTUs of energy. So you can rewrite it just as you did right there. BTUs in 1 barrel. Oh gosh. 1 barrel. Okay. But I want to know how many calories there are in a gallon. All right, let's see if I can sort of start off. It looks like I may be able to start off like I did up here, right? Because at least this one down here will give me how many BTUs there are in a barrel. I mean in a gallon, because I cross out the barrels. And I have my 42 gallons. This is an equality that is given at the very top of the page. All right, now I want to know how many calories of energy this 1 gallon, let's write gal so I don't think it's grams again, will provide. So that means that BTUs of energy, somehow I have to be able to convert from BTUs to calories. And let's check my list to see if there's a BTUs to calories. Yep, there is. The third one where it says 1 kilowatt hour is equal to 3.4 times 10 to the 4 BTUs equals 8.6 times 10 to the 5th calories. All right, so I have an equality between calories and BTUs, both units of energy. So I can use it. 8.6 times 10 to the 4. Pretend that that's beautifully written. Divided by BTUs. What was BTUs? 3.4 times 10 to the 4 BTUs. And you can do some of the little shortcuts from the previous one too if you want. Of course, you have to cancel out your BTUs. Make sure they cancel out. I'm going to end up with calories per gallon, which is the correct unit I want. I can get rid of this 6 and write a 1. I can get rid of this 42 and write a 7. And then I just start actually multiplying, dividing these numbers and multiplying, aka adding these units of 10. Okay, and then double check my answer here, whatever that ends up being. I believe I got that one wrong. All right, percent growth rate, this is the other one I got wrong. So remember I gave you that little mnemonic, original minus new, divided by the original number, times 100%. All right, so I already know what the original is. The original is the 5 million. And I need to find out my new population by making sure that I add up all the new people that come into this city. 100,000 plus 300,000 is going to give me 130,000 new people coming into the city. But I want to subtract how many people leave the city or die from the city, right? 700 plus 50,000 is going to be 120,000 people leave the city somehow. Okay, so that's going to mean that in the year I add 10,000 new people to my population of 5 million, right? So my new population is going to be 5 million plus the 10,000. So 5 million, 10,000. You don't really have to end up doing that after all, because you're going to have to subtract it again here. 5 million minus 5 million, 10,000 is going to be 10,000. So the original minus the new is going to end up with 10,000 in the numerator, and original is the 5 million. Hey, lots of zeros. That's actually not so bad to work with. It's nice and easy. Let's cancel out some zeros, some zeros, some zeros, some zeros. There we go.